Hello guys, good evening. Today we'll do a quick revision of all the topics that we have covered so far in the course so that we can go through them, and if there are any doubts you can come back to me and ask me any questions. So the first thing that we have learned during the course is how to start thinking about making programs. For doing any type of tasks, we need a set of steps which must be followed to accomplish that task. And while following that task steps, we have to follow step by step process. So a formal representation of a step by step set of tasks to achieve a large complex task can be depicted in form of a flowchart. Flowchart has multiple shapes that we have discussed. First is the start and stop. Start and stop are represented by ellipse shape. And any type of user input, whether we are taking numbers, we are reading some data from the user, or any type of output which we have to give to the user, like we are printing some data out, we are sending a message to the user, are represented by parallelograms. In a flowchart, the flow of the program is represented in the form of arrows. So we can follow the arrow and we will reach from start till the end. So we have covered start, end, and we have also covered input and output. Now during the execution of the program or execution of steps, we may need to come across certain conditions, and these conditions are represented in a flowchart using rhombus. A condition can always have two outcomes, a yes or a no. Both of these outcomes are represented using the arrows. So we also label these arrows as yes and no to represent each branch. The yes branch is followed when the outcome of the condition represented in the rhombus is true, and the no branch is followed when the outcome of the condition represented in the rhombus is false. For any program, we can create the flowchart and we can represent the set of steps in a formal notation. So if you have any doubts related to the flowchart, please do reach out to me and ask your doubts. Let's move on to the next section. In the next section, we have covered the basic entities of Python, which included the basic data types in Python, which are numbers and strings. We have talked about various types of numbers there, and we have also performed operations on the numbers. Likewise, we have also dealt with strings in Python and we have performed operations on the strings. There are certain container types also in Python. These types are called container types because they contain values. Few of the container types which are there in Python can be named as lists, dictionaries, and tuples. We have exhaustively seen the list and the operations on the list during our course. Likewise, we do have tuples as well in Python, and we do have something called as dictionaries. The fundamental difference between a tuple and a list is the tuples cannot be modified, but the list can be modified. So you can presume a tuple to be a list which cannot be modified. We are going to go in depth and cover tuples as they arise. But right now you can understand that the syntax of the list is representing data values in form of square brackets. But if you want to create a tuple, you are going to use the same representation, but you are going to use brackets, and you can create a tuple, but tuple cannot be modified. The third container type is dictionaries. As the name suggests, the dictionary are a set of values which are represented in key value pairs. So key value as in, we will give a key, and based on that key we will get the value of that attribute. If we were to refer to a dictionary, we will get a list of the words in a dictionary, and corresponding to the word, the meaning of that word is listed out in the dictionary. Same way, in the programming language such as Python, the dictionary contains a set of associative array attributes, which means we get a name corresponding to a value. When we give the name, we get the value of that particular name. We are going to cover dictionaries also in detail, but this was for just quick reference so that we have the base idea of what dictionaries are. During the course, we have seen how to create variables, how to set value into the variables, how to access the variables, and how to use these variables during your code. We have also seen control structures like if, else, while, for loop. We have also seen functions and procedures. We have used some inbuilt functions, and we have also seen how to define your own function. We did also see various modules and packages that come pre-built along with Python. These modules can be installed and used during our programs. Modules are a set of code and functions which are written by somebody else or by ourselves as a group, and we just want to use them in our program to reap the benefits of the functionality that is implemented. We have not discussed exceptions yet, but to give in short, exceptions are something different from a regular flow. So let's say if we were to follow a flow and we expect the outcome to be X, however the outcome comes out as Y, then Y is an exception, as in it is not the normal output which was expected, but we got something different. And these exceptions are also to be handled during the code. So let's say we are trying to perform an addition operation, but the addition failed. When the addition failed, it is an exception. It is an exception to the normal flow. And when such exceptions come, we are going to log them down, or we are going to take certain actions based on the exception that we are trying to catch. We will cover exceptions when they come during the course in a normal flow. Next, we talk about files and standard libraries. Standard libraries we have already used, like a math library, where we got advantage of the functions which are implemented in this library, like taking a square root, finding the square, and finding cosines, or finding the value of standard constant pi. We have also looked at the files, which included opening of the files, closing the files, and reading from the files. During today's class, we are going to do a quick revision of these as well. Classes and instances are yet to be covered during the course. These are the fundamental object-oriented concepts. Let's move further. So we have covered a list of data types which are available in Python. The first data type that we have covered is a string. Anything in double quotes is represented as a string. Subsequently, we have covered numeric data types like int, which stands for integer, which contains all the numbers negative and positive including 0 but without the decimal part. Then we have talked about a float. A float is any number negative or positive but includes a decimal portion. So whenever you have to use numbers with decimal portion in your code, the data type used or the data type that should be used is float. There is a third type of numeric data type, and that is called complex. We generally do not use complex, but complex data type is represented or with the value j and used in complex scientific calculations. At this moment, we are not going to cover this data type. Then comes sequence types. Sequence are a set of values where there are more than one values and one value comes after another. We have worked on lists in detail to cover the sequence data type. I have also explained you in today's class that there is another sequence data type called tuple, which is exactly same as the list, except that tuple cannot be modified but the list can be modified. There is another data type called a range. This is nothing but an inbuilt function within Python, and it can be used to generate a range of values in Python. So let's say if I use the range function and I say range 6, this basically means Python will create a list of numbers starting from 0 till 6, a range of numbers starting from 0 till 6. So range is used to generate a dynamic set of values within the code by Python. I did also shared a brief about the dictionary data type, which is a mapping data type in Python. The dictionary is a set of key value pair. So whenever somebody asks you about dictionary, the first thing that should come to your mind is set of key value pairs, where if I give the key to you, you will give me the value of it. We are going to cover dictionary in detail as well, but this is for baseline reference. Then there are certain data types as set, frozen set. These will be covered later during the course when we start working on them. There are also certain binary types which may be out of scope of this course, but they are used in very specific scenarios where we are dealing with memory directly and we need to perform certain operations in the memory, and that's why they are called binary types. Then there is one of the logical data types in Python. This data type is called Boolean data type and is represented with bool. This basically means true or false. So the acceptable values for the bool data type are true or false. Next, let us cover certain examples of these various data types that we have discussed. So in this example, a is a variable and the data type of the a variable is a string. The string is represented in double quotes or single quotes. Here, hello world is a string and is assigned to variable A. Python has one beautiful way of initializing variables, and variables need not be declared in advance, but as you assign some data to the variables are also get declared, as well as the data is also assigned to the variable. This step of assigning the data first time to the variable is called variable initialization. So here we have declared and initialized the variable A, and we have assigned a string data type into this variable. For B, we have assigned a number 20, and 20 is of data type integer because it does not contain a decimal part. If we talk about variable C, we are assigning 20.5 in variable C, and the data type of C variable is float because it contains a decimal part. For D, as I did discuss before, complex numbers in Python are represented using the J symbol. So when corresponding to the number, you also associate a J suffix to the number, then it gets converted into complex data type. The use of complex data type is there in very specific scientific calculations and may be out of scope for the tasks and the set of activities that we are doing currently. The next data type that we have already seen is a list, and a list is associated to a variable by using square brackets. We have also seen that the list can contain various types of data within the same list. So I can have one string, second number, third float, and fifth another list as parts of a parent list. Here the variable E is of data type list. If we talk about F variable, then F is of type tuple. I did explain to you before that tuple is nothing but a list, but a not modifiable list. So you can think of tuple as very similar to a list which is not modifiable. The tuple is represented or initialized using parentheses. The tuple is created using parentheses, where the list is created using square brackets. The tuple elements can be accessed exactly in the same way as you access the list elements. The tuple elements will have index 0, 1 and 2. Same way the list E will also have index 0, 1 and 2. Next, let us discuss the data type for G. So the data type for G is a range, where we have used the range function to generate a list of values up till 6. When I give range 6, it will return me all the values starting from 0 till 6. Note, 6 is not included here. So you are going to get values 0, 1, 2, 3, 4 and 5. Let us now talk about H data type of H variable. Data type of H variable is dictionary. I did explain to you that dictionary data type contains key value pairs. Look at the example here. In this example, H data type has two keys and two values. The first key is name and the value of that key is John. The second key is age and the value of that key is 36. Hope this is becoming a little clear to you that in a dictionary we give key value pairs. Here there are two keys, one is name, another is age. Each of the key has a value. The name key has a value John and the age key has a value 36. Then let us talk about set data type. Set data type in Python is represented using curly brackets and we can give the strings or numbers within the set data type. Frozen set as represented here for the variable j, as the name explains, it is frozen. This cannot be modified. The set can be modified but the frozen set cannot be modified, and it is a fixed set of values that are represented here and assigned to variable j. Next, we did discuss that there are various keywords in Python which are the standard words which are used by the language, and therefore these should be used in the program for the specific purpose that they have been defined for, which also means you must not create your variable with the name of a keyword. So I should not create a variable name with the name false because false is a keyword. We should not use keywords in variable names because keywords are reserved for a special purpose by the language and should be used only for that purpose. It should not be used as variable names. I hope this is clear to you. Next, let us talk about various operators in Python. Python has 7 categories of operators. The first set is the set of arithmetic operators, which are used for mathematical calculations. Subsequent, the next set is a set of assignment operators. These are used for assignment of values. We are going to look at them, each one of them, along with examples. Next are comparison operators. These are used to build conditions in Python. So wherever you have to create a condition and based on that condition you have to perform certain actions, you will need to use comparison operators, which will be helpful to compare one value to another. The next set of operators in Python are called logical operators. There are 3 logical operators in Python: and, or, not. Subsequent set of operators are identity operators. Then we have membership operators and we have bitwise operators. These 3 categories are used for very specific purposes and may not be required during this course. However, we are going to cover as the need arises. So let us look at all of these operators as a quick note and a revision. First, let us talk about mathematical operators or arithmetic operators. These operators you must be already familiar with. We have plus, minus, multiplication, division. Then we have modulus operator. Modulus operator is nothing but a representation of remainder in Python. When you use the modulus operator, you will get the remainder which is left after the division. So if we look at this example, if we divide 5 by 2, then we will get 2 to the 4, but 1 will be remainder. So as an answer to this print statement listed here, we are going to get 1 if we use modulus operator between 5 and 2. Next, let us talk about exponentiation operator. So we know this as power symbol in mathematics. So power in mathematics, as in 2 to the power 3, is represented by 2 times star in Python. So if we say 2 star star 3, that basically means 2 to the power of 3, and the answer to that will be 8. Next, let us talk about slash slash. 1 slash in Python represents division, but if we put 2 slash, that basically represents floor division. Floor division basically means that you will get the rounded off number to the lowest value of the dividend. So if you divide 15 by 2, then there will be a remainder 1. 15 is not fully divisible by 2, but you will get a remainder 1. And if you were to fully divide, then the answer will come as 7.5. But if you use floor division, your answer will be 7. Next, let us look at set of assignment operators that are available in Python. Equal to symbol is used for assignment. So assignment basically means giving certain value to a variable, which is also referred as assigning a value to a variable in a programming language. And as the name suggests, to give a particular value to a variable, we are going to use assignment operators. These assignment operators are extended to perform multiple functionalities. And let us look at these operators. So the first assignment operator is a equal to sign. If we say x equal to 5, then we are assigning the 5 value into the variable x. And this is known as assignment of value 5 to the variable x. Let us take the next operator, which is plus equal to. The plus equal to operator is a short form of saying x is equal to x plus 3. So if we were to write a statement like x is equal to x plus 3, then instead we can use x plus equal to 3. X plus equal to 3 will be same as the result of x plus equal to 3 will be same as x is equal to x plus 3. So you can either write x is equal to x plus 3, or to represent it in short form you can use the plus equal to assignment operator, and you can write the same statement of x is equal to x plus 3 as x plus equal to 3. Respectively, you can use minus equal to operator, multiply equal to operator, divide equal to operator, modulus equal to operator, floor division equal to operator, power equal to operator. These operators can be used for their respective functions with plus. Sorry, I meant with assignment. Let us look at the next set of operators, and these are comparison operators. When you have to build a condition, you will need to use comparison operators. The various comparison operators that are available are greater than, less than, double equal to, which basically means comparing the exact values on the both sides, not equal to, which is represented as exclamation equal to, greater than equal to, or less than equal to. The greater than sign is used to compare if value of x is greater than value of y. The less than is used to compare if the value of x is less than y. Double equal to is used to check whether values of both are equal. Not equal to is used to check whether the values stored in two variables are not equal to each other. Greater than or equal to returns true if the value of operation on the right side, a variable on the right side is greater than or equal to the value on the left side. The less than and equal to returns true if the variable on the right side, the value of the variable on the right side is either less than or equal to the variable value on the left side. So here, if x is less than equal to y, then the value of this condition will be true if the value of x is either less than y or it is equal to y. Let us move forward and look at the logical operators in Python. There are three logical operators in Python. The first one is AND, second is OR, third is NOT. AND operator can be used to join two conditions which are given on both the sides of the operator. So you are going to write condition 1 and in between you are going to use the AND operator and then the condition 2. The result of this expression will only be true when the condition 1 is also true and condition 2 is also true. So AND operator returns you a true result only in one case, and that is when condition 1 and condition 2 both are true. In all other cases, AND operator returns a value of false. OR operator is little different from AND operator. The OR operator returns a true value if either condition 1 is true or condition 2 is true. There is only one case when the OR operator returns a false, and that is when the conditions on both sides of the OR operator are false, which basically means if you are using condition 1 or condition 2, then the result of this statement will be false only when condition 1 is also false and condition 2 is also false. In all other cases, the result of this condition is going to be true. The NOT operator is used to reverse the result of the condition against which it is used. So if the result of your condition is true and you use the NOT operator, then the total value will be false. If your condition is false, and you use the not operator with your condition, then the end product or the end result of that condition will with not will become true. So it reverses the value outcome of your condition, and that is what not operator is used for. Let us move forward. When we have so many operators in Python, it is obvious that there could be an expression created which uses more than one operators from Python. And in case there are more than one operators used in an expression, then which operator must be resolved first is given by precedence table. The operator which has highest precedence in the precedence table is the first executed operator. So the precedence table defines the importance of the operator, and that is what follows the execution sequence. The highest precedence operator will be executed first, and the lowest precedence operator will be executed last. The top end of the precedence table contains the power operator or the exponentiation operator, which basically means that the power operator has the highest precedence, and if it is used in any expression, then this is the first operator that will be executed. The OR operator contains the lowest precedence, and this will be the last operator that will be executed while evaluating an expression. So while we are creating any expressions which use more than one operators, we must always keep in mind the precedence operator order of the operators, so that we exactly get the results for which we have created that expression for. Precedence plays very important role in identifying the result of the expression, and therefore should be always kept in mind. Let us now discuss lists in Python that we have covered in extensive detail. List in Python can be declared using square brackets and giving the values which are elements of the list between the square brackets. The list or the list elements can be accessed either using indexing. Index in list always starts from 0. We have played a very good archer and thief game to understand list indexing, and I hope all of you remember it. The list can be either accessed using indexing, which starts from 0 to number of elements in the list -1, or the list element can also be accessed using negative indexing. The negative indexing starts from -1 and up till the number of elements in the list, but in negative term. The negative indexing always picks elements from the end of the list and moves to the front of the list, whereas normal indexing from the list picks up elements from the beginning of the list, starting from index 0 and goes till the end of the list. We have also looked that the list can be of various types. The list can be number list, where the list comprises of only numbers. Either you have integers or you have floating points in those lists. There could be a string list where you have only strings within the list. or there could be a mixed list, and mixed list can contain strings as well as numbers or other types of list within itself. Subsequently, we have also looked at nested list, where we had one list part of another list, and when one list is part of another list, it is also called as nested lists. So we have looked at all combinations of the list where we had mixed list and nested list and string list and number list. In this example here, you see at the top there is a variable declared champ list, and this is pretty much a combination of multiple list elements with multiple data types. In the champ list, there are 1, 2, 3, 4, 5 elements. Out of these 5 elements, the 3 elements are list again. So if we see here, 1, 2, 3 is the first element of champ list, and in it is a list by itself. Then apple and kiwi, which is a string list, is the second element of the champ list. The third element of the champ list is an integer 20. The fourth element of the champ list is integer 30, and the fifth element of the champ list is again a string list. If I wanted to access the first element of the list, then I would just write champ list 0, and champ list 0 will give me the first element of the list. Champ list 0 will give me first element of the list. Let's say if I wanted to access 3 of champ list, this means I have to access the first element of the list, and from that first element I have to access number 3, and if I go by indexes, the index of number 3 will be 0, 1 and 2. So I must write champ list 0 and 2. This is represented in this notation, which is represented by point number 13 here. So if I were to access nested lists, then I am going to write the name of the variable, and in the first square bracket the base element or the first element, which is the list itself here, so which is champ list 0, and within that element whatever is the index of the element that I want to pick. Here the index of element 3 is 2 because indexes start from 0. So I will say 0, 1, 2, and therefore if I were to write champ list 0 and 2, then it is going to give me the number 3. Next, let us revise the slicing of the list. Slice is basically picking out certain part of the list from the list. So slicing basically means pulling out a specific portion of the list. For this, we have a specific operator in Python, which is the colon operator. The colon operator in Python is used for slicing. The syntax of slicing is you will give the variable name, and within square brackets you are going to give the start index. This is the index of the element from which you want to start picking up your slice. Then you will separate by colon, and you will give the stop before index. This is stop before index. That means here you have to give the index of the element before which you want to stop. So let's say I have to pick the list of 20, 30 and 50 in this example. Then this basically means that I must stop before 70. And to stop before 70, my stop before index should be 3. My start index will be 0. So I have to start picking up 20, then I must pick 30, then I must pick 50, and I must stop before 70. So if I give 0 to 3, that basically means I will get the result as 20, 30 and 50. The step can be used as an extension of slicing, and this is useful when you want to pick, let's say, alternate numbers. Let's say if I have to pick up 20, then I have to pick 50, then I have to pick 90. By default, the step is 1, which basically means I pick up 20 first, then the next number will be 30, the next number will be 50, next number will be 70, and next number will be 90. But if I give step 2 and access the same list, then the first element will be 20, then 30 will be skipped, and the next element will be 50, 70 will be skipped, and the next element will be 90. Giving step of 2 will skip one element in between. If I give here step 3, then it is going to skip 2 elements. So if I give step 3, then straightway from 20 I am going to go to 70. So this way I can extract a part of list from the list by slicing the list. Let us move forward and understand the formal differences between a list and a tuple. We have already seen that the lists are created using square brackets, whereas tuple is created using parentheses. Let us look at their differences now. The first difference is list is mutable, which basically means the list can be modified. You can add more elements to the list, or you can remove certain elements from the list. Whereas in case of tuple, the tuple is not modifiable. Once you create the tuple, it is going to remain like that. You cannot modify tuple. Let us look at the second difference. When we talk about moving or accessing all the elements of the list one by one, the elements of the list can be accessed in slower form as compared to tuple. The elements of the tuple can be accessed with comparatively faster speeds. The list is useful. Let's look at the third difference. The list is useful when we have the need where we have to dynamically modify the data by either inserting new data or deleting certain existing data. Because lists are modifiable, you can add or delete elements to the list. And in case when there are operations where we have to only access fixed set of data and we don't have to do any modifications, then we can use tuple. The next difference is that lists consume more memory, whereas tuples consume less memory than the list. If we discuss the next difference, then since lists are modifiable or mutable, there are several built-in methods available in list to add more values or to delete certain values. Whereas since tuples are fixed data types where they cannot be modified, there are no built-in methods available for the tuple. The tuple is fixed and cannot be modified. If we talk about the last difference between them, then point number 6. Since we are performing operations on the list, there could be chances of certain errors occurring during those operations. Whereas in tuples, the tuples are created in the beginning and later on are not modified and only used, and such a case reduces the chances of any errors that may occur while performing any additions or modifications to the elements of the object or tuple. Therefore, tuple is less prone to errors and lists are more prone to errors or unexpected changes. This completes our revision 1.